Hi, and welcome to NASA Launchpad. I'm your host, Justin Garcia. Innovation is incredibly important to new discoveries, but you've probably heard the old saying, if it ain't broke, don't fix it. So just how do you know when to use what you already have and when to start with something new? Well, a team at NASA has the answer, at least when it comes to a series of very successful Earth-observing instruments. SAGE, or the Stratospheric Aerosol and Gas Experiment, is an instrument that scientists have used several times since the 1970s to learn about Earth's atmosphere. Of course, the engineers are constantly modifying the design and updating the technology, but the same basic instrument has been used all these years. You see, more than 30 years ago, scientists realized there was a problem with the Earth's protective coat of ozone. It was thinning. The SAGE family of instruments was pivotal in making accurate measurements of the amount of ozone loss in Earth's atmosphere. And then, when international regulations to reverse the loss of ozone were enacted, SAGE also played a key role in measuring the ozone recovery. Over the last 30 years, SAGE technology has shed light on how aerosols, water vapors, and other gases interact with and affect our atmosphere. Today, SAGE is still the best for the job, and NASA scientists are preparing to send the third generation of the instrument into space. However, not just any spacecraft will do for SAGE 3. Scientists have been keeping it safe, waiting for the day that it could go where no continuous Earth-observing instrument has gone before, the International Space Station.
Well, for the scientists it's great because the orbit that it's in allows us to take science between around -60 to +60 degrees. So that's quite a major range of data that the scientists can get, especially in the equator, which is great for the scientists. Operational-wise, it's great for us because we're allowed to talk or communicate with the payload almost continuously, which you generally can't do for most satellites.
The space station in orbit has a specific direction that it points. They call it the yaw, pitch, and roll, so the three directions that move. Because it's such a large structure and it's got a lot of things that it's trying to accomplish, that attitude, those yaw, pitch, and roll numbers change over the course of weeks, months, and years. So because our instrument's designed to point at the Earth the whole time, we needed some way to be able to correct those changes and get our instrument pointed back in the way it's supposed to be.
You're oriented so that this is facing Earth, and our scan head can account for this direction. But if there are any discrepancies in how the ISS is oriented, the hexapod, which is this guy in the blue, can help orient your scan head in azimuth and elevation, so you're pointing in the right direction.
SAGE 3 will be the first continuous Earth-observing instrument ever to grace the ISS. But something else makes this SAGE different than the rest: its use of the moon.
You take observations with solar occultation only where you see sunrise and sunset. So now if you can take moonrise and moonset, you basically, in some sense, kind of doubled your measurement capability. But you can also probe different places and different times. The lunar occultations only occur at a local nighttime condition. So with the sunrise, sunset with solar occultation, you're seeing it at sunrise and sunset. With lunar occultation, you can see it in the nighttime. And many of the gases in the stratosphere have cycles to them. For example, nitrogen trioxide, NO3, is only present really in concentrations at nighttime. But you need to understand that to understand the chemical balances going on.
SAGE is one of NASA's longest-running Earth-observing programs, and we know that long-term collection of this type of data is necessary to truly understand both the fragility and complexity of our atmosphere. Take a look at this photo. That thin blue line, that's Earth's atmosphere. This image really shows just how delicate our atmosphere is. Not only will SAGE 3 help us understand more about our tenuous atmosphere and ozone, but it can also help us understand the impact that human activities have on Earth's atmosphere. Information that may prove vital as we look to solve the challenges of Earth's changing climate. Until next time, I'm Justin Garcia. Thanks for watching.